Alright, welcome back. This video covers section 11.4 from your textbook, and we are going to be talking about graphing different types of functions. Now, we've already talked about graphing quadratic functions, and we've also talked about graphing absolute value functions. We're going to review how to graph absolute value functions, and then we're going to take a look at a couple of new functions. The square root function, what does the graph of that look like? And also cubic functions. So let's get started. Let's jump into it. We're going to start out, like I said, by reviewing what the absolute value function looks like. And you remember what its shape is, what it generally looks like? Hopefully you're thinking to yourself that it looks like a V shape, and the reason why is because if we pick some x values and we plug them into the absolute value of x, which remember this gives you our y value. F of x is equal to the absolute value of x. F of x is equal to the absolute value of x. We get some points that we can start graphing. So I like to generally start with -2, -1, 0, 1, and 2. And when we plug in -2, the absolute value of -2 is +2. Which gives a point, an x point of -2 and a y coordinate of +2. And I can take the absolute value of -1, which gives me +1. So that gives us a point -1, 1. Absolute value of 0, 0, which gives the point 0, 0. Absolute value of +1 is +1. Which gives us the point 1, 1, and then finally, if we take the absolute value of 2, we get 2, which gives us the point 2, 2. And then if we put those points on the graph, we'll see that nice V shape that we just referenced a few minutes ago. So there's the point 0, 0, then we have the point 1, 1. You'll remember when we graphed these before, we talked about how it kind of had this pattern where it went up 1, over 1, up 1, over 1. That's the point 2, 2. And then it goes up 1, over 1 the other way. This is the point -1, 1. And then we also had the point -2, 2. And we get this nice V shape. So hopefully that's somewhat familiar to you. And we also talked about how to shift these sorts of graphs. We talked about how to shift them. And so if we take a look at a shifted version of the absolute value function, you remember that this negative in front makes it open down. Now, another way of saying opening down is this means the same thing as reflect about or across. Oops. Now another way to say open down is we could say that it reflects across the x-axis. In other words, if we took this V shape and we reflected it so it went across the x-axis, it would open down. It would be a V that opened down. We also know that x's, remember what we said? X's, we do the opposite here. X's are liars, so this means left 3, and this means up 1. Now, in this absolute value graph, the lowest point, just like in the parabola, we still call that the vertex. So we can talk about where the vertex is for this graph. It's going to be left 3 and up 1, which takes us to the point -3, 1. and we expect it to open down. Now, since it's opening down, we can kind of use that pattern where we go down 1 over 1, down 1 over 1, down 1 over 1. Now we have the vertex and 2 points on each side. This is the point -2, 0. So point -1, -1. We have the point -4, 0, and -5, -1. It gives us that nice downward V shape now. We could also graph this using our graphing calculator. Let's remind you how to put that in the graphing calculator. So if you go back to our y equals and clear out your function, and we're going to first type in negative, and then to get the absolute value we go and we hit the math button, and we right arrow over to number, NUM, and the first option there is ABS, which stands for absolute value. So if you press enter, then type in your x plus 3, because we want the absolute value of x plus 3, close parentheses, and add 1. It should look like this. If we hit graph, there's a graph we expect. We could get some points by going to the table, and you see all the points that we used on our graph are also showing up in this table. The other question that we want to ask is, just like we did before, what's the domain and range of this function? Well, you should notice that the domain, just like always, there's no restrictions on the domain. It keeps going to the right and it keeps going to the left. However, for the range, are there restrictions? Yeah, it goes down, so it hits negative infinity, but it stops when we down here, where everything from negative infinity up to, what's the highest y value? Positive 1, and that's a bracket. So that's absolute value, and again, this should be review. Now, what's not review is this new type of function, which is called the square root function. It's pretty obvious, I think, where the name comes from, because it's f of x equals the square root of x. And you can see here the graph is in here, already on this graph. And where do those points come from? Well, the same place when we introduced the absolute value function is that we have x, and then y comes from f of x equals the square root of x, which gives us an ordered pair. So if we, for example, were to choose 0, this would give us the square root of 0, which is 0. So that's the point 0, 0, which we see on the graph right there. It's the point 0, 0. And now we could plug any x in here as long as it's positive or 0. Notice, could we take the square root of, say, -1? Well, we could, but it's 1i, or just I, which is not real. Can we graph something that's not real? Absolutely not. So this one, there is a restriction on the domain. It's not all x's, it's only x's that are positive and 0. Let's pick some more x's. Now we know the x's we have to pick are positive and 0, but we also might want to pick them for graphing purposes as x's that you can take the square root of. For example, I could take the square root of 1. The square root of 1 is 1, which gives us the point 1, 1, which we see here on the graph. That's the point 1, 1. What about 2, though? Do we want to choose 2? Square root of 2, can we take that? We can, but it's a decimal number. So I would prefer to pick our next whole number which we can take the square root of, which would be 4. Square root of 4 is 2, so this gives us the point x is 4, y is 2, which again we see on this graph over here on the left. That's the point 4, 2. What might be the next x value that we would want to choose here? Think about that for a sec. What can we take the square root of? Hopefully you're thinking to yourself 9, because the square root of 9 is 3. So another point on this graph would be the point 9, 3. Now I'm not going to put that one on the graph because we don't have room for it in the graph that we drew. But this graph, because of that point, you can see we can continue to go out here to the right. It's going to continue on. So what's the domain? We already just talked about this. Remember, we can't plug in x's that are negative. So in this case, the domain is everything from 0 to infinity. This is our first graph we've actually looked at where there were restrictions on the domain. First type of function. We can't plug in any values over here. It stops. It stops on the x. It stops at 0 and it goes to the right. The x values start at 0 and it just keeps going to infinity. What about the y values? I didn't ask you for the range, but the range, is there any restrictions? Yeah, again, the range is also 0 to infinity because it never goes negative. The range goes from 0 up. As it keeps climbing, it's going to hit all these positive y values, but never go negative. So again, just like the last one, we can tell we're a shifted version of this basic square root function where it's going to move to. It's just, we're going to shift it. So just like the last ones, here inside the square root with the x, remember x's are liars, so this means they shift left by 2, not right by 2, and this means they shift up by 3. So instead of this graph starting at 0, 0, we expect it to start at the point 2, 3, and go up to the right. Now, you could pick some points there. For example, you might want to pick something like -1, because if you choose -1, that makes square root of x plus 2 into the square root of -1 plus 2. -1 plus 2 is 1, which equals 1. But then we also have to add 3 to that. So this is going to be 1 plus 3. This is going to give us a y value of 4. -1, 4. Because of this plus 3 here, you're going to be adding 3, which gives us 4. And so that's another point on this graph, and you could continue to plug in x's that will allow us to take the square root. For example, if I chose x equals 0, that would give us 0 plus 2. That's not going to work. Or if I chose x equals 1, that's 1 plus 2. Can we take the square root of 3? No, but the next one, 2, gives us the square root of 2 plus 2, or 4 plus 3. Square root of 4 is 2, so 2 plus 3 is 5. So this is the point 2, 5. And you could continue in this fashion, or what's another thing we could do? Rather than finding all these points by hand, we could use our graphing calculator. So let's try to put this in the graphing calculator. Go back to our y equals. clear out the previous function. And in the first y equals, let's put the other square root, the first problem. We had just the square root of x. That was the unshifted version. And then let's arrow down here to y2 and put in our new one. So we have the square root x plus 2 plus 3. It's our new graph. And if we graph it, there's our first one that we had in the graph above, and then there is our new one. And basically the entire graph has just been shifted left 2 and up 3. So as a reminder, remember we could go to our table here. Look at all these errors. What do those mean? Well, we're concerned with the y2 one here in our new graph. Look, everything to the left of -2 gives us a y value that's an error. That means it's not in the domain. -3 is not in the domain. Oh, just notice here there's a typo here on my graph. This should say -2 here, right? -2, not +2. -2, 3. There's no points after that. That's where it stops. It's going to start here and climb up to the left. Now let's get one more point to put on here. If we go back to our graphing calculator, we saw the point -2, 3, -1, 4. These are decimal versions. Let's keep going down. Should see 2, 5. We already got that point. When x is 2, y is 5. Our next one is 7. Because if I take 7 plus 2 in my function, 7 plus 2 is 9. The square root of 9 is 3. 3 plus 3 is 6. So 3, 4, 5, 6, 7. 7, 6. That's our next point. So there's our nice square root function. Again, is there any restrictions on the domain here? Yeah, we already kind of talked about this. The domain only goes from -2 to positive infinity. It's not going to be any values to the left of -2. Okay, so hopefully that makes sense to you. Let's talk about the last type of function here. This is the cubic function. And if we take a look at f of x equals x cubed, let's go ahead and make our table like we've been doing here. We have x, we have f of x equals x cubed, and this gives us some values. If we choose x equals -2, let's even do, -2, -1, 0, 1, and 2. Well, -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. So we have some points here. We have the point -2, -8. We have the point -1, -1. We have the point 0, 0, 1, 1, and 2, 8. Okay, so we can put those on the graph. See what kind of shape this cubic function looks like. And you can see here that my graph is not including all my x's and y's, so I need to go actually down here to -8. So let's extend this down a little bit. Go down to -8. So -2, -8 is going to put us right about there. That's -2, -8. Then we also had -1, -1. We have 0, 0. We have 1, 1. We have 2, 8. So this cubic function kind of has this look to it. Okay, so are there any restrictions on x values that we can plug into x cubed? Or if I look at the graph, will the graph stop anywhere? Well, is there places it won't go? Or as it goes up to the right, will it, as it goes up to the right, will it cover all my x values? Or as it goes down to the left, will it cover all my negative x values? The answer is, yeah, there's no restriction. The domain is negative infinity to infinity. Keeps going. And what about the range? Again, there it's negative infinity to infinity. There's no restrictions on what y can be. Okay, so we can talk about shifting here again. We don't just have f of x equals x cubed. We know it's going to have that shape, but this particular graph is shifted to a new place. Again, right next to the x, it's a plus 3, which means we do the opposite. We go left 3, and then outside the cubic part, we have a plus 3, which means we go up 3. And then here, since this isn't really a graph that opens up or down, we want to go back to that first example where we said that, yeah, the negative in front says it opens down if it's absolute value or a quadratic function, but we can also think of it as reflecting across the x-axis. So what I'm saying by that is, instead of my graph looking like this one, this top part, it kind of goes up like this, is going to be reflected across the x-axis. It's going to look more like this. So if we reflect across the x-axis, our graph we expect to look more like this little red one here. So I guess this one is f of x equals negative x cubed. But the center point is not this 0, 0. Let's talk about where we can move that 0, 0 to. We can move it left 3 and up 3. So left 3 and up 3. The center is right there. I'm expecting this graph to look something kind of like this. Now, it's not good enough to just put the center point on there that's been shifted left 3 and up 3. We should get all our other points. And again, we can make a table, or we can use the graphing calculator. Now, if you wanted to make the table, the best place to start, I think, is with our center point. Our center point had an x value of negative 3, and let's look at some points on each side. So we could look at negative 4, negative 5, and then negative 2 and negative 1, and this should give us a good idea. We know that when we have negative 3, the y value should be positive 3, because this is negative 3 plus 3 cubed plus 3. But negative 3 plus 3 is 0, so this whole part wipes away and we just get 3, which means our point here, x, y, is negative 3, 3, which we already know. We know it's going to include the point negative 3, 3. Now, just like with the last ones, though, doing all these calculations, it kind of gets a little bit hairy. I mean, we could do it. We could say this is negative 4 plus 3 cubed plus 3. Negative 4 plus 3 is negative 1. Negative 1 cubed is negative 1. But then we have this negative 1, so it makes a positive 1. And positive 1 plus 3 is 4. So we know this is the point negative 4, 4. But what could make this easier rather than plugging all these x values in here? What could we do to save us time? And hopefully you're saying to yourself, use the graphing calculator. That's what I would do. So I'm going to go ahead and erase this curve here, and I want to come up with the exact points. And rather than doing this all out by hand, let's finish this problem by using our graphing calculator. So if we turn this back on and we go back to our y equals, let's clear out those square root functions. And let's put our new one in. First of all, we have negative. Then we have parentheses. X plus 3, quantity cubed, plus 3. That's how we would go ahead and enter this into our graphing calculators. Then if we press graph, it's exactly the shape that we expect it to be, but in order to actually get the points that we're looking for, remember we go to table, and I need to arrow up here to get to our negative points. So we have negative 5, 11 as a point. At the point negative 5, 11. We also have the point negative 4, 4, which we already found. Take a look at some other points that are on there. We also have negative 2, 2. We have negative 1, negative 5. And so that's enough to give us a nice picture of what this looks like. Hopefully that makes sense. And again, the domain can be anything. I can plug in any x value here. It's going to cover all my x's, this particular graph. So the last thing we're going to do here is look at working backwards. If we actually see a graph, can we use the graph to determine how it's been shifted and then figure out what the original function was? So notice this particular example, we have a square root looking curve. So our actual function should have this form. So what should we think about next? How are we going to determine what the h and k are that go in here that tell us to shift? Well, this is a shift. Remember, we always start at 0. This is a shift right by 4 and then up by 1. Remember, the right is what determines the number in here next to the x, so this is going to be h is 4 and k is 1. So it makes our function f of x equals the square root of x minus 4, and we know it's got to be minus because it's moving to the right, so we think opposite. And we have plus k, which is 1. That's our function. So a couple things to think about when you're doing these type of problems is, number one, you got to first determine, is it a quadratic function? Is it a absolute value? Is it a square root? Is it a cubic? And so you get the right form. We notice that this one looks like a square root. It has that curve. So then we get that form, and then we got to talk about, okay, what's the shift? There's always a shift most of the time. So anyway, that should do it. Thanks for your time. Make sure you do your self-check, and we'll see you in class.